Hi everyone, welcome to this video on the mystery behind ChatGPT. ChatGPT and GPT technologies in general have been gaining in popularity in such a way that many of you people qualify them differently, starting from job sucker to future human killer. Assertions are innumerable. In this video, I will reveal the so-called mystery behind this AI, and to do so, I divide this presentation in 4 points. First, we will look at what GPT is versus what it is not. Next, we will look at ChatGPT as a whole of two in one, comprised of an automated chat system fueled by a GPT technology behind. Next, we will look at the secret of GPT technologies. And finally, we will put everything together to wrap up. My name is Theodore Kabangu Nkashama, an AI researcher here at Hanyang University, Erica. I am a software engineer and a certified data analyst. Welcome to this video, and let's get started. What GPT is and what it is not. The rise of GPT technology has got an unprecedented speed that makes you people feel that AI is the most dangerous enemy ever faced. But hold on. This is what AI is and what ChatGPT is particularly. For sure, it's a tool. It remains a tool. ChatGPT remains an automated chat system powered by artificial intelligence. Nothing more, nothing less. Okay, you said, well, if that is the case, now, what does it comprise? Well, we will look at ChatGPT as a whole of two in one. I will talk about two major components of ChatGPT. First, we will look at the automated chat system as the first major component. That means you have the user interface you use that makes it easy for you to write your text as a request and get a feedback as a generated text or an image or a video, I don't know. So that's what I call the conversational technology, the conversational part of ChatGPT. It is triggered by human interactions, and responses provided by this system are just the highly scored output based on computation. And despite the variety of possible output the system can give you, they all result from a static knowledge base. It means when the model was trained, it has been trained on a static knowledge base that doesn't evolve as our real world information evolves. There are a couple of techniques that came out after the release of GPT models and their development to do what they call fine-tuning, to give some additional capabilities to the models. But let's look at the second major component. That's GPT. You said, okay, we got it about automated chat system. What about GPT? GPT stands for Generative Pre-trained Transformer. This is actually the operational mode of the system. And it is the mechanism that takes your text as a request and works on it to output a response. Let it be a generated text or an image, I don't know what. Okay, with that said, here are some key points to remember. First, the system works on your request. It's all about computation, not thinking. Let me say it again. It's all about computation, not thinking. The word generative in GPT means it generates the most meaningful next word. No creativity is involved. And that's how the model was trained to generate the most meaningful output. Next word. The word pre-trained means the model was trained on several billions of human language resources. GPT-3 has been trained on 300 billion of tokens. Think of that. And the word transformer sounds magic to begin with, right? But it's not about transforming your request into response. It's all about transforming, first of all, your request as written in natural text into numbers, because computers only understand numbers to work on your job or on what you're doing, what you want them to do for you. Okay. You said, well, what are you getting all that from? Let's hear from those who made ChatGPT. I took two citations from one from John Schulman and another one from John Lake. Two of the engineers, two of the team members who worked on ChatGPT. Let's hear from John Schulman. He said, ChatGPT was trained in a very similar way to InstructGPT. InstructGPT is actually the model that has been released prior to ChatGPT release. And it used a technique called reinforcement learning from human feedback. This is the ChatGPT's secret sauce. It means the model has been trained and it has been submitted to humans, you and I. We have been using it in the early stage of the use of ChatGPT. You can remember that people used to send feedbacks. And based on the feedback, the model could figure out what kind of responses human like. And based on that kind of responses, the model would be able to output the same kind of responses over the time. Now, from John Lake, we hear this. There are things that are specific to producing dialogue and being an assistant. Things like, if the user's query isn't clear, it should ask follow-up questions. You see that in ChatGPT. Follow-up questions like it wants you to clarify something or give more details about what you really want for you to get the job done. Okay. It should also clarify that it is an AI system. It should not assume an identity that it doesn't have. It shouldn't claim to have abilities that it doesn't possess. And when a user asks it to do tasks that it is not supposed to do, it has to write a refusal message. That's pretty much easy to understand. And we know that it's what this tool is doing up to this stage. Well, you will say, so there have been many things going on out there, and so many people came with several images, fake things that have been generated by GPT models. But this is the truth about the model. It's just a tool. It doesn't think. It just output things. Well, now let's see the secret of GPT technologies. We have come to what I believe to be the crucial part of this presentation. Guess what? Behind the GPT technology lies a transformer, referred to as a large language model. Well, transformer is known as one of the breakthroughs in natural language processing. And it is well known for the advent of what we call attention mechanism, the ability of a machine learning model to understand the context of words in a sentence. Well, with that said, let's understand what kind of transformer is behind GPT technologies. Originally, a transformer was made of two components: an encoder comprised of a set of encoder blocks and a decoder comprised of a set of decoder blocks. Research progress and development in this area made it possible to come up with what we can call today encoder-only transformer models, the case of BERT model, or decoder-only transformer models, the case of GPT family. Now I believe you got it. GPT lies under the category of what we call decoder-only transformers. And with that said, let's understand the architecture of this type of transformers. The scary magic inside the LLM decoder-only transformer lies in every single decoder block. Remember, I told you a decoder is comprised of several decoder blocks. In GPT-3, the first one, we count 96 blocks inside the decoder. And that's how it was possible to take a text in English like "hello everyone" and translate it into French as you see it in ChatGPT to say "bonjour tout le monde." Every single block inside the decoder-only transformer performs two main tasks. The first one is what we call mask task multi-headed attention. It's a way to compute self-attention as already introduced in the original transformer, but this is so particular. That's why we call it mask task multi-headed attention. Now, the second task is what we call pointwise feed-forward transformation. That will consist of neural networks taking several elements of your request, referred to as token at this stage. We will see that further, and work on them to compute and finalize the work up to the classification task. Now, let's look at how all that is done inside a decoder block. Think of these decoder blocks as aligned vertically, and before getting to the very first decoder block, we have to cross preprocessing tasks, and we number them as 3 preprocessing tasks. The first decoder block starts its work, and a final step after the last decoder block completes its work will be followed by what we call a residual connection. I've said that. And when the last decoder block completes its work, then comes the second, the classification herd. The classification herd will now give you the output. Okay, now I will structure them in three different sub-processes for you to understand them clearly. The first sub-process is what I call preprocessing. Preprocessing starts with taking your natural text, like hello everyone, and work on it on the preprocessing stage. The first step in preprocessing is the tokenization. It converts your natural words into tokens. Now, tokens are just several different words of your natural text, and separated by special characters and the end of line character, just for the machine to understand. The second step of preprocessing is embedding. Now, embedding consists in converting your tokens into integers. We had tokens that were just characters, alphabetical characters, and they will be converted into integers. Then we have embeddings. Now, after the embedding, we have what we call positional embedding. That will add positions to several tokens we have in our token string. So I refer to token string as the concatenation of all the tokens of that we got after we have converted our natural text. Okay, then at this stage, the first decoder block starts its work. It starts with a normalization. Normalization will take positional embedding output and transform it for the attention to be computed. The attention is computed using three kinds of vectors called query, key, value vectors. They are used inside the model just to compute the attention, to compute the context. So, how the sense of the sentence we had may change based on the context in which we use every single word we focus on. So attention is all about focusing on a couple of words that can draw our attention and change the context of the sentence. Next to that is the residual connection after the attention computation. Residual connection will take the input before the attention computation and add it to the output after the attention computation. Okay. Now, the output of the residual connection will be normalized before starting the pointwise feed-forward transformation task. Okay. Now, after pointwise feed-forward transformation starts, we have every single token in our token string flowing in a separate neural network, and the network is going to work on that token to output a probability of that token. Again, in feed-forward transformation, each token becomes an output for a particular feed-forward neural network. And each neural network each neural network outputs a probability, and that probability is then added to what we call a residual connection. There will be now a sum of every single input to a feed-forward neural network with the output of this feed-forward neural network. So as taking the input and adding it to the output for every single feed-forward neural network. Okay. Finally, the output of that residual connection becomes the input for the next decoder block. So what we complete after feed-forward transformation and the residual connection, what we complete at this stage is just for one single block. Now it goes on and on for every decoder block in the line up to the last one. And the last one will output its probabilities. And once these probabilities are output, they pass through what we call a classification head. The role of this classification head is just to compute the most probable word found in the vocabulary. Now, every model has got a vocabulary as a base. I talked about static knowledge based in the beginning of this video, and we will compute the most probable. It means the closest possible word that could be taken as the next word. That's how it's possible then to be given hello everyone as input, and as output get from ChatGPT something like bonjour tout le monde. It's by following this process, putting everything together. Despite fast-growing research under this hype, we still have far to go. You know, many of you guys heard about what we call hallucinations about large language models. It's all about prompting something and getting a response that doesn't match really what is asked. I told you remember that the model computes, and if it cannot find something that is close to what you really want, it just come up with anything it can find, because it has been trained to craft something that could be human related, or liked by human. Okay, the description discussed so far is just a standard decoder only transformer architecture in order to improve on training stability and generalization of most LLM implementation. 3 key points deserve our attention. First of all, it's the order of normalization operations. In different LLMs, we have different ways of normalizing the input, and that gives the difference. Second, we also have different normalization strategies. It's not only about how normalization is done, it's also about where is the normalization done. Maybe a little bit in the beginning, at the end, before the residual connection. Okay. Now, finally, we also have self-attention strategy as a key element. You will see that the way self-attention is computed is different from an LLM to another. We talk of flash attention, the way the attention is computed can differ from an LLM to another. We also talk about multi and grouped query attention. That's just another way of computing attention. In fact, model architectures used by most modern LLMs, though much larger and modified in nuanced ways, largely match the architecture of the original GPT model. Remember this. The power of modern LLM lies in decoder-only transformer model. The generative process goes through three sub-processes I talked about earlier. We have what we call preprocessing, comprised of tokenization, embedding, positional embedding. Then we start the job inside every single decoder block. We start with a normalization, followed by masked multi-headed attention, then followed by residual connection, and we also have a normalization before going to what I call pointwise feed-forward transformation, also followed by a residual connection. Then, after the last decoder block ends its job, then we go to what I call token classification at the classification head. Thank you for your attention. That's all.